Okay, I'm about to solve question number 2 from the 2022 AP Calculus exam, and I have not yet read the question. So you're going to watch me solve this in real time. So here we go. So F and G, by the way, this is only on the AB. Question number 1 was on the AB and the BC. But so we have two functions, F and G. They give you the graphs. Looks like a good old-fashioned area volume question. So okay, so I'm going to go to my calculator. This is a calculator active question. I'm going to clear out all of my work from question number 1, and I'm going to go ahead and define my two functions. F of x is the natural log of x plus 3. That is correct. And I'll define g of x to be x to the 4th plus 2x cubed. Two fairly clean functions for a calculator problem. And they give you one intersection point. They do not give you the other. They do say that the other point is at x equals b, and I'll deal with that later. Okay, find the area of the enclosed region. And for questions like this, you absolutely must set it up because these calculators have a cute, sexy command where you can find the bounded area between two functions. I'm going to start by graphing these two. Yes, that is correct. And I'll graph g of x there, and you can see the bounded area. They tell you that intersection is at x equals -2. And I need to find the other intersection. So I'm going to go ahead and go menu, analyze, intersection, and go between the two. There's my intersection point, and I'm going to store that for B because they tell me in the description that that is B. So 0.781 is B. So I'm going to go to my calculator now, and I'm just going to do a little bit of work here. I'm going to make a note that f of x is equal to g of x at the x values of -2, which was given, and the other one was 0.782. And I'm going to make a note that that is stored in my calculator for B. They also define that in the problem as B. And the area between those two curves, the top curve is the natural log graph, which is f of x. So for question A, it'd be the antiderivative from -2 to B. I'm going to call this capital B in my written work, of top curve, which is G, minus bottom curve, which is F, dx, and that is about as nice a question as they can ask. So I'm going to go here, shift plus -2 to B of g of x minus f of x, and I may have done that backwards. If I did, it will give me a negative answer, and it did, but that means the answer is actually 3.6035, which you can round up to 4, or you can truncate to 3.603. I'll write 3.6035. All right, so number B, on -2 to B, h is the vertical distance, and is h increasing or decreasing? Okay, so the vertical distance between those two would be the top curve minus the bottom curve. So I'll define h of x to be my top curve, which is the natural log, which is f minus the bottom curve. That is how you measure the vertical distance between 2 points, is top minus bottom. And they want to know, is that measurement increasing or decreasing? And if anything is increasing or decreasing, you need that thing's derivative. Very interesting. They just asked a question like that on number 1 as well. So repeat questions. So h prime of -0.5 is, and we'll go to the calculator and use the derivative at a point command. So menu, calculus, derivative at a point. I'm plugging in -0.5 to the first derivative of f of x minus g of x. F of x minus g of x. Enter, and I'm getting -0.6. -0.6. Therefore, the vertical distance between F and G is decreasing because h prime of -0.5 is negative. There we go. Let's move on to number C. The region enclosed by the graph is the base of a solid cross-section circle. Oh, this is nice. So nice. All right. So we have squares and we are perpendicular to the x-axis. So I always make note of what shape my cross-section is and what variable we will use. The area of a square is side length squared. So my setup will be the antiderivative of side length squared dx, and the side length of that square will be the top curve minus the bottom curve, which will be f of x minus g of x. And we'll take all of that and roll that into an antiderivative. We're going from -2 to the intersection point B. I just want to make sure that they're not changing anything on me. I don't see anything changing. And I will make sure I square the difference of f and g. I personally prefer to do top minus bottom. However, if you did the g minus f, then squaring it will end up negating that difference, and you should end up getting the correct answer anyway. So let me go to my calculator again, shift plus -2 to, tab, there we go, -2 to b of parentheses f, just use my keyboard, f of x minus g of x squared dx, hit enter, and I'm getting 5.340. All right, number D. A vertical line. Thank you. I have students in here interrupting me. All right. A vertical line in the xy plane travels from left to right along the base of the solid described in part C. Okay. The vertical line is moving at a constant rate of 7 units per second. Find the rate of change of the area of the cross section above the vertical line with respect. Okay, so we're looking at this is a unique question. So here they have finally thrown a curveball at me, something I haven't seen in a free response question before. So we are dealing with squares. So the area of that cross section will be a square. So the area is still going to be top minus bottom squared. If your vertical line is moving from left to right, your x's are changing. And it says we are moving from left to right at 7 units per second. So left to right would be a rate of change of x. So dx dt will be 7 units per second. Find the rate of change of the area of the cross section. So we're trying to find dA dt. Yeah, when x is -0.5. -0.5. Okay, so I'm going to need to find dA dt first. So dA dt would be 2 times, it's a chain rule, f of x minus g of x times the derivative of the inside, which would be f prime of x. And since I'm differentiating with respect to t, I need to multiply that by a dx dt minus g prime of x dx dt. And now we will plug in dA dt. It is asking find the rate of change of the area. So dA dt at the point x equals -0.5 is going to be 2 times f of -0.5 minus g of -0.5, and I'm going to run out of room here, times f prime of -0.5 times dx dt, which they tell us is 7, minus g prime of -0.5. And I'm going to have to shrink this up and give me some more room to write. Okay, there we go. So minus g prime of -0.5 times 7. And then I need to evaluate those 3 pieces of information. So let's see, how do I want to do this? I could do this in one big step in my calculator, but that's dangerous. All right, so let me punch all these in. I'm going to do all this over here. So I'm going to write f of -0.5. I need g of -0.5. I need f prime of -0.5. And I need g prime of -0.5. And I'm going to punch those in my calculator. F and g will be easy. Here's f, g of -0.5. I need the derivatives of those. So I'll go to my calculus derivative at a point. I'm going to plug in negative 0.5 to the first derivative of f of x. And then I'm going to repeat that and do the same thing with g of x. And there are my values. And so negative 0.916 is really my only super ugly one. So my answer is going to be 2 times f of negative 0.916 minus g of negative 0.5 was negative 0.1875. So plus 0.1875 times f prime of negative 0.5 was 0.4 times 7 minus g prime was 1 times 7. And I would stop there. I would stop there on the AP exam. If you want to I'm going to pause this and simplify it just for those of you who are curious what the cleaned up answer is. See you, Connor. And I'll be right back in the blink of an eye. Okay, if I punched that in correctly, I'm getting negative 0.92718, and they do not ask for units. And so I feel happy with my answer, and I'm done with question number 2.